Thank you all for having me. I am Tony Casparro. I've been in Netflix for a super long time, half my marriage actually. And I'm here to talk about two things today, engineering and product. I think a lot about building products, what's meaningful, what can actually get delivered, and what's the engineering behind it. And so I'm going to combine both in the talk today and hopefully make it interesting with a bunch of examples for you. The first one is a game called Robo Rally. Has anyone ever heard of this game? Really? Okay, great. This was invented back in 1992 by a guy named Richard Garfield. And he had this idea, and he said, I want to make a game that has a board game, it's got metal pieces, it's got tokens and dice and all these different things, and he brought it to a bunch of different manufacturers and said, I want to build this game. And everyone said, it's too complicated. You're putting too much on the board at once, there's too many things happening, we can't create it for you. You have to come up with a simpler product that we can put out there. We want to work with you, make something simpler that we can actually deliver. So he came up with this idea called Magic the Gathering in 6 months. Magic the Gathering then went on to be the first billion-dollar game in Hasbro's history, with millions and millions of players all around the world. And it came from forcing him to say, don't overbuild. Come up with a better, smaller solution, and we'll put that out there. He eventually did get to build Robo Rally with his profits, but it was not the ultimate player that he thought it would be. So in this case, he delivered, he did not over-engineer. He pointed it right the way. Another example, not in the product space, I promise that we'll actually get to code in just a second. But this other example is about my dad who lives in Oxnard. Over there, they had this big, big swath of land. And the plan was to build this huge, huge development. It would have a shopping mall, booths, all kinds of fairs and stuff like that, have streams and rivers and boats and all kinds of things like that. And so they started developing it. They had the big plan, they had the big architecture, they paved this massive, massive area and put all the infrastructure and groundwork in place. And 18 years later, it looks exactly the same. And I drive by it every single time I visit my dad, and every single time it reminds me, be careful about how big you reach to start and never amount to actually delivering anything. And so in this case, nothing delivered, plenty of over-engineering. One more non-code example is Netflix. According to my sources, and I've been debating on this, according to my sources, the reason it's called Netflix is because Reed eventually, or had the idea, it was going to eventually involve streaming. I will have this streaming to people's computers one day, but I can't pull it off to now. I could start working with all these manufacturers and providers and whatnot, but I need to come up with a simpler idea first. Let's throw some DVDs in the mail, we'll build our business, and eventually we'll create, 18 years later, one of the most dominant streaming engines in the world on every single device on the planet with plenty of support for everything, but this is not where he started. And so he delivered without over-engineering. So let's go to a practical example, one that actually happened to me. And I've been through a lot of different over-architecting in my time, but this one is specific to something I recently worked on. And I'm going to preface this by saying none of the libraries I'm about to mention are bad libraries, but everything has a time and place on when you want to use it. And so we had this site. It was a pretty simple site. It's about 8 pages long. It was for servicing information about our servers and our architecture. And so we started using Redux. Let's bring in some data. We need to use it in different spots. Redux seems like a good choice. Okay, a little time went on. Okay, we actually need Redux Thunk now. We need to do some asynchronous actions, pull some stuff on the fly. That'll make it a little more responsive. We'll go there. Okay, well, now we need something to do the coordination. We have middleware. So the middleware will, by the way, this is from like 5 years ago, so things have gotten better. But we need some middleware. The middleware will help us orchestrate so that different things can have different actions and respond to different places. Okay, now we're pulling in too much data. Now we need a normalizer. Now, if you're not familiar with normalizing, it's the idea that data can be replicated many different times of the same object, so store it in one single object memory and point to it instead of replicating it over and over again and taking up a lot of memory in your application. But now that you've normalized it, we had to use, and this is all true, we had to use reselectors to get the data out of the normalizer. When I want to use it, we had to pull it back out. And it turned out the performance on that was so slow, we had to use a real library called reselector so that we could get this stuff out in an efficient manner. And so without showing too much, here is the diagram I had to memorize so that I knew how to edit our application. Now keep in mind, this is an application of 8 pages. It's not that complex. It shouldn't be that complex. And this is what I had to know when I first started for the program. So my job has primarily been taking things and making them more simple. So I took this and we honed it down to here. Obviously, we threw out a bunch of things. We didn't need any more. We've moved to component architecture, hooks, getting rid of Redux. That makes things a lot easier. But it could have been this way at the start. We could have made a simpler application. And so the start of the talk is basically, why do we do these things? Why do we end up in a place where we end up with a product we go like, oh, I don't even want to go in there. It's going to be so complex, I don't even want to look at it. And here's what happens. First, we're thinking about future needs. We think, oh, you know what? This is going to happen in the future. I'm going to actually build a server here, and it's going to talk to this microarchitecture over here, and all these different things. And we're trying to anticipate future needs that never actually arise. With that application I just talked about, the person who wrote it said, well, we're actually going to have like 30 pages, and we're going to have all kinds of different users and all that. And that just never came up. For 4 years, it's been an application that's 8 pages, and it just is very cumbersome to work with. The second one is very common. I follow this one, which is premature generalization. Essentially, hey, I think this is going to be really useful in the future, so let me generalize it, make it a kind of robust so we can use it later on. And it ends up never getting used again. You move to a different library, and you spend all this time prematurely generalizing something that just doesn't get used that way. And the third one is a fear factor. If I don't do it now, how much is it going to cost me in the future? I better do it right now, because I'm in the code right now, and I'm going to make that choice. The problem is, there's a probability factor here. If I do that today, it's going to cost me X amount of time. But in the future, maybe it's only 25% probable I'll have to do it. And you need to weigh that probability with the time it will cost you. There's a funny diagram I really like, especially when bringing on new engineers, which is about how complex your code is when you start coding. So obviously it's very simple. You're just getting into the basics, let me move some things around. And I absolutely went through this myself. I went through a time where I was gang of 4 pattern, I've got abstractions and interfaces and flywheels and whatnot, and you think you're so clever, and then later on you're like, oh, it doesn't have to be that way. Simplicity is a good thing. We can keep it simple and build great applications. So let me offer my consideration for a better path forward. One is building small with leverage. By the way, those are just notes on the screen for me, not for you, just a reminder of what to talk about. So building small with leverage really means don't build like a big architecture with a lot of different pieces unless you absolutely need it. Build with the smallest approachable pattern that will get you to where you want to be. And the leverage part is about pivoting. If I build something strongly typed to this one type of object, I'm going to get in trouble really fast. Think about using generics. Think about instead of parameters for functions where you say parameter 1, 2, or 3, passing in an object. If you think you might need it, just give yourself a little flexibility for that. Availability to pivot going forward. 2, avoiding pre-optimization. Now, I put a quote up here from my friend at Microsoft because even at that level, at the 100,000 or whatever employees they have, he just has said this quote on Twitter the other day, which is that pre-optimization is a mind killer. It will lead them into all kinds of paths where they're sitting in meetings for months trying to figure out what to build, what's the most optimal way, when what they should do is put code on the ground with a small implementation and try it out. And so he just said that, and I really liked it. I have a little note in there about pioneers and settlers. If you ever looked up the pioneers, settlers, and there's a third one about software development, it's really interesting. And the idea is that sometimes you're going in to just try something out. You're going off into the wild west. You don't know what's out there. You're just going to try a little bit. And there's a separate phase for we know it works. We know it's a great idea. Now is when we build the foundation, and now is when we grow it from there. The third one is about delivering and iterating. Obviously it's an important one because if you just talk, or you build a big microarchitecture and never actually leads anything, you could end up in a bad spot. I have an example from my own history here where we built a product. It was for order processing. And we built for 6 months on this really interesting way of doing order processing. And it was perfect, and it was great, and it had flexibility and sustainability, and it could grow and everything, and we were beating the market. And all of that work, all of that designing and perfection of making the perfect software solution was ultimately thrown out. We had nothing to compete with anymore. We were gone. And that was the end of that code. So without throwing everything out, what kind of future-proofing is valuable, though? One is tests. I have a side project where I do stuff with Magic the Gathering cards, which I absolutely love. And I do a parsing engine for reading the cards. And it's been evolving over 13 years now. And those tests save me every single time I go in to iterate and change something, because I will know if I have broken something. So tests, not 100% code coverage, but strictly targeted tests are really valuable. I think 100% code coverage is a lovely dream, but not, once again, the most valuable thing you'll need right now. And the second one is clean code and comments. So comments are for you and your future self, which you will thank yourself for every time. They are super easy to write. and they are not a waste of time, in my opinion. So as a final thought for wrapping this all up, favor shipping over perfection. That Shopatron, oops, I said the name. That example of that software company I worked for, they favored perfection. It did not get them anywhere, and they were ultimately beaten out. So ship your product, get feedback, iterate, build small, and focus. 2 is don't overcompensate for future needs. If you don't need it right now, don't build for it. You can think about it, but if you waste that time engineering and building something that's way too big and complex, you might end up not needing it or just throwing it out in general. And the 3rd one is that simplicity is beautiful. I put this picture of a magic card, which I think is beautiful up there. The card game itself was beautiful. It allowed itself to pivot and to have 30 years going on of Magic the Gathering. It is a great example of building with a great amount of pivoting and simplicity. So that is me. Thank you very much.